a lot has changed in the world of AI since we first spoke. And I wanted to really get your thoughts around everything that's happening, where it's going. But I think it's good to just get a basic idea for people. What is the first version of AI? Like, what was that we
Oh
can kind
boy.
of coin and define to just realize where it's going? And
Yeah,
everybody
yeah,
has
right.
different
Well, so I
interpretations,
can
but I
tell you
just
the
want to know
history as I
yours.
know it. I mean, back, the term AI was coined by John McCarthy, who I knew. We didn't get on that well, but that's a different story. But what's that? Why
Why
was
is that?
that?
Why is that? Just
It's a complicated
intellectual
story. So
clashes
to
between you
begin
two?
the AI story, in 1956 there was this conference at Dartmouth where John McCarthy coined the term AI, and one of the things John McCarthy did in the years right after that was invented this language called Lisp, which was kind of a very early computer language, very early but sophisticated in conception computer language. It was hard to implement, and it wasn't really implemented fully for decades. So the reason John McCarthy and I perhaps didn't see completely eye to eye was that Lisp he saw as being the only language in which you could implement artificial intelligence and what was then thought to be an important piece of artificial intelligence, which was things like symbolic mathematical computation. Well, in 1979, I kind of got into building my own kind of symbolic computation system, and it wasn't practical to use Lisp at that time. It was just there weren't good implementations and so on. So I used this then newfangled language called C, which isn't very newfangled anymore. But and John McCarthy kind of never forgave me for that, and I think that was kind of the was also the beginning of realizing that I mean, while Lisp is very was very interesting language, it wasn't yet very practical. Had history worked out differently, Lisp would have been kind of a much more prominent language today. It probably would have been the thing that had implemented my system in too. But anyway, John McCarthy coined the term artificial intelligence back in 1956. Kind of the backstory of that whole thing was that when electronic computers were first kind of coming on the scene in the late 1940s and so on, the typical description of them was giant electronic brains. So people had the idea from very early on what computers are going to do is automate thinking kinds of things. And people kind of assumed that that wouldn't be terribly hard. And that was kind of in the 1950s into the early 1960s, it was kind of like, yeah, we just build a slightly bigger computer, we'll be able to automate thinking just like we've been able to automate kind of making a bulldozer or something like that. Um, it was There were a couple of different approaches that were taken. Well, actually, as one indication of kind of the way people were thinking in the 1960s, where a lot of kind of money and effort was put into AI. One of the problems of the time was the Cold War, and people were thinking, well, there are occasionally these sort of high-level diplomatic exchanges between, the U.S. and the Soviet Union and so on, and they had this idea that, well, in those exchanges there would be some interpreter who'd be, translating Russian to English, et cetera, et cetera, et cetera, and they were like, we're really worried the interpreter is going to mislead everybody, and it's going to lead to World War III or whatever. So let's put a machine in place instead. Let's have an automatic translator. Yeah, way better, right? No
Way
possibility
better.
of human
Yeah.
error. Well, people thought that was going to work in the 1960s. And it's actually very interesting to read what people wrote in the early 60s about kind of AI and what was going to happen with AI and the idea that, kind of we were a species that was mostly going to go down in the history of the earth as being the thing that created the next species that was AI and so on. And it's really, really funny to read these things now because honestly, pretty much word for word, they're the same as what people say today, with the one exception that a bunch of the kind of language of, men will do this, so to speak, has been, adjusted in modern times. It will be people will do it. Everything else
But
is the
everything
same.
else is pretty
So people have
consistent.
been
Like
been sort of
humans.
saying and thinking the same
Mm,
things about kind of the future of well, essentially giant electronic brains for a long time. But there were really two approaches that, well, first thing in the 1960s, there were two different approaches that were taken to AI, and there continue to be two different approaches today. There was kind of the symbolic approach and the statistical approach. The the idea, the symbolic approach was kind of the thought that you can have sort of a computational representation of the world, and you can have your AI kind of figure out things in the world in a kind of computational fashion. That's actually been an approach that I've been deeply involved in for a very long time, but that's one of the approaches. The other approach was the statistical approach, just saying, forget about having rules for how the world works, just say, we notice this and that and the other thing, let's extrapolate from what we notice, let's just do the statistics of the world to guess how things work. The main approach that got used there was neural networks. Neural networks are famous today, but neural networks are an incredibly old idea. I mean, I've actually been researching a bit the ancient history of neural networks, and it goes back even much further than I imagined. It goes back to the mid 1800s.
How far does it go back?
So
Oh,
what happened was, it was
wow.
a sort of neural nets were all entangled with the question of how our brains actually work. And so the people had looked at brains under microscopes. There was a chap called Golgi who figured out in, I think, the 1870s how to stain nerve cells. Because when you look at, a slice of brain tissue under a microscope, it just looks really complicated. You can't see anything. Golgi figured out this way to stain it so that some tiny fraction of the cells would turn purple. And then you could see those cells that had turned purple, and you could kind of see the pattern of those things. There was for a while, there was a big sort of dispute between Golgi and a chap called Ramani Kajal, because Golgi thought that sort of every nerve, that you would see these sort of nerve cells and that they were really all connected in one big net. Ramani Kajal thought they were all separate cells that had sort of synapses, gaps between them. But that was a dispute of the late 1800s. The two of them even disagreeing violently about that won one of the early Nobel Prizes in together for studying those kinds of things. I think there were more things to give interesting Nobel Prizes to in those days than there are perhaps today, but that's a different story. In any case, the people knew that nerves were electrical, because actually the way electricity was discovered was by Volta and people kind of noticing that frog legs kicked when you gave them electric shocks. So people kind of knew it's electrical, and then they kind of knew there's a network of nerves in the brain. And what did that mean? Well, by the 1870s, people were talking about how it might be implementing logic in the network of nerves in the brain in some kind of electrical way. This is before there were really electrical machines that did anything like logic. So then, well, the next probably big step was 1943. A chap called Warren McCullough and a chap called Walter Pitts. Warren McCullough was a neurophysiologist and psychiatrist. Walter Pitts was a very young math person. They worked together, wrote a paper about kind of the logical theory of neural nets. That paper is kind of the foundation of everything that's been done since. It kind of laid out this way of idealizing the thing that might actually be in brains, but idealizing it in sort of a mathematical way. Well, computers didn't yet exist. By 1946, there were starting to be electronic computers. By the mid 1950s, people were implementing kind of this idea of neural nets on early computers and on special purpose computers that they'd made particularly for doing neural nets. And particularly there were this idea of the so-called perceptron, which was a kind of a way of having sort of this very simplified artificial neural net that would do kind of statistical, would figure out, given an image, it would sort of figure out from the statistics of that image what was in the image. It all was going reasonably well, but there were some glitches. So a famous glitch was there was some trial for the military of these things where there were a bunch of pictures of tanks which had tanks in them and other pictures that didn't have tanks in them. And the perceptron did really well figuring out which pictures had tanks in them. But then somebody realized that all the pictures with tanks were taken during the day and the pictures without tanks were taken at night. So really all the perceptron was doing was something very trivial. And this is a repeated issue with trying to understand what's happening in AI. Is what you see just a consequence of some feature of the data that you didn't happen to notice, but it's sort of trivial? Or is it that you're seeing something that's kind of a deep figuring out that's being done by the AI? So then, actually, so what happened after that was in the early 1960s, a person I actually knew pretty well named Marvin Minsky, who was a kind of AI pioneer who'd originally been interested in neural networks. He wrote his Ph.D. thesis about neural networks, even built a neural net machine. But he kind of decided perceptrons and all things neural nets are trivial. And he and a chap called Seymour Papert wrote this book about perceptrons, which argued that perceptrons and neural nets can't do anything interesting. Game over. So by the late 1960s, everybody said neural nets are doomed. They'll never do anything interesting. They're all trivial, et cetera, et cetera, et cetera. And so sort of AI at the time was, if there was going to be anything that happened with AI, it was going to be sort of on the symbolic side of figuring out rules for how the world works, and sort of trying to take things like ideas from psychology and sort of take the ideas which had been expressed kind of vaguely in psychology and try to sort of tighten them up and make them things that you could implement on a computer. That was the idea. So then we get to the beginning of the 1980s, and I was by this point sort of actively interested in these kinds of things. And well, let's see. This history is a bit complicated. The thing that was sort of the dominant theme of AI in the 1980s was these things called expert systems. And the idea was you would have sort of a rules-based way of describing the world that you would learn from an expert. Somebody would essentially write the rules based on some expert in geology or some expert in medicine or something like this, would write the rules, and then the computer would be able to do whatever the expert could do. That was kind of the idea. Now, I have to say, and that idea was kind of a significant idea in the 1980s about how AI would work. Meanwhile, I myself have been interested in kind of how you would do things like math sort of automatically, how you would do symbolic math, algebraic math automatically. That had been viewed as a kind of a thing that if we could do this, we'd know we had AI. It had been viewed as sort of a big test case for AI. But I in 1979, I already mentioned that I started building a system called SMP, Symbolic Manipulation Program, that did kind of symbolic math and many other kinds of symbolic things. And it did it in a way that I would never have claimed was anything like how brains do it. Meanwhile, I myself have been interested in kind of how would you take kind of the knowledge of the world and make it somehow automatically accessible. It was a thing I've been interested in since I was an early teenager. And I kind of, having had success in sort of building up the symbolic computation system, I kind of got to thinking, could I do something with sort of vaguer knowledge that wasn't as precise as the kind of knowledge in math? And so I got to thinking, this is around 1980 or so, I got to thinking, how would I make something that deals with that? And I kind of assumed that to make a thing that could deal with vaguer kinds of knowledge, I would have to kind of make a brain-like thing. I would have to sort of solve the general problem of artificial intelligence. And so I started thinking about how would I do that, and I was interested in kind of pattern matching and how would you sort of fuzzily match, is that roughly a picture of this or not? And I had a bunch of ideas, never figured out how to do it at the time. Meanwhile, neural nets had kind of a comeback. This is around 1982 or so. There was a couple of sort of experiments that were done with neural nets where it was like, wow, they're able to actually do things. And the fact that they were sort of, squashed flat by the perceptrons analysis wasn't really right. If you had deeper neural nets that had sort of more layers of computation in them, then they might be able to do something interesting. So, I did some experiments on neural nets. I could never get them to do anything terribly interesting. I kind of lost interest in those things. Meanwhile, in my own personal trajectory there, I had started my first company that was sort of aimed at doing sort of mathematical computation kinds of things through a series of probably not great business decisions of deciding that, I should bring in other people to run the company and things like this. We ended up getting venture capital, and the venture capital was like, these expert systems things, they're amazing. You should go chase that particular, shiny direction, so to speak. So the company kind of pivoted to having, a division of the company doing expert systems kinds of things. And that's actually kind of strange to realize that the company changed its name eventually to Inference Corporation. That was probably 1983. And I hadn't even thought about that in so many years. It seems so very modern today. It was an AI company. It was doing expert systems AI, and the company built all kinds of things for I don't know, it built early credit reporting systems or credit assessment systems. It built a bunch of testing systems for NASA and things like this. So it was really doing in those days kind of symbolic AI. I wasn't much involved in that side of the company. The company eventually went public in a very undistinguished IPO sometime in the 1990s, but I hadn't been involved with it for a long time by that time. The other thing that happened in AI in the 1980s, so I told you this is a long, shaggy story, but it's kind of interesting to understand if you want to know where AI is today and kind of what the roots of what's going on today have been. So the so I guess two other things of note happened in the 1980s with AI. There was a time when Japan was viewed as a country where kind of, it just copies American technology. Everybody was kind of very down on that. The Japanese government had this great idea. They said, let's do a research project that's going to jump ahead of everybody else. It was called the Japanese Fifth Generation Computer Project. And it was a project in, I forget when it started, early 80s sometime. It was a project where Japan was going to solve AI. And their methods, they were using particularly a language called Prolog, which is sort of a Lisp-ish kind of thing, but it had a particular idea about problem solving, which doesn't work out so well in the end. But that was another kind of injection of, AI is coming type thing. Japan is going to solve AI type thing. There's another piece. Another piece in the 1980s was the kind of as I mentioned, sort of the rebirth of interest in neural networks. And a bunch of people, including the people who sort of continued working on that till the present day, people like Jeff Hinton and my friend Terry Sinofsky, who were kind of the early people who got interested in, could neural nets really be made to do something interesting? They talked about it as parallel distributed processing. And it was a sort of big mixture of thinking about things computationally and thinking about actual brains and dissecting brains and trying to figure out how they worked and so on. So again, that was sort of a thing that was happening in the 80s. By, I would say, end of the 80s, early 90s, this stuff basically hadn't worked out. And people said, AI is doomed. And everybody was kind of, everybody who might have been saying they were doing AI didn't say they were doing AI anymore. And AI was really at a very low ebb for quite a long time. The thing that relaunched AI was something that happened in 2011. Actually, that aforementioned person, Jeff Hinton, had been continuing to study deep neural nets. And something people, including myself, were just like, I don't know, I don't think anything interesting is going to happen here. But he had been studying, trying to do image recognition, trying to tell, is this a picture of a cat or a dog or whatever? There was a big collection of images, ImageNet, that existed, and there were these annual competitions for, who can recognize images best. Well, a student of Jeff Hinton's left a neural net training kind of by mistake for a month, trying to, going through millions of images, saying, with the neural net being told, there's a cat, there's a dog, there's a cat, there's a dog, and, trying to tweak the neural net. That's how neural net training works. Tweak the neural net to get the answers right more and more often. So it was like, okay, it was kind of a mistake. The computer was just sitting doing this. It was an early GPU computer. And it was, before throwing the neural net away, I guess I don't actually know the every detail of what happened in those days, so to speak. But it was like, okay, let's just try this neural net, see how it does. It did pretty well. It won the ImageNet competition that year. That was a big wake up call that, neural nets are back and they're able to do interesting things. Kind of the buzzword at the time was deep learning. And so that time, people got very excited about that. I have to say, I myself had been just about to use image processing to just sort of make little functions that would count, you know, I don't know, people in an image and things like this, and do that by kind of a bunch of image processing hacks. And my friend Sarah Stanovsky had said, no, 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 we're going to be able to do it with neural nets one day. It actually arrived within the year, and I'm happy I didn't do that project because that project would have been kind of dead meat. So in any case, the what then happened was sort of a big sort of wave of excitement about neural nets and deep learning and so on, particularly applied to image identification. And that problem was kind of solved at some level. And by solved, I mean, you get it right 90 something percent of the time or whatever. And that's kind of typically the story of machine learning. You get it right, 90, 80, 95% of the time, something like that. It's not 100%, but it's not even clear what you mean by getting it 100% right. I mean, it's like, is that dog that has been given a cat suit or something, should that be a dog or a cat? It's hard to define what the answer should be. So it's hard to know whether you were got it exactly right. In any case, the thing that's also interesting to notice in terms of kind of the evolution of AI is that the things that one had by 2012 or so, we were making image identification systems and so on using these neural net ideas. They're not that much worse than what one has today. In other words, in the last 13 years or so, things haven't, in that particular domain, haven't improved that much. It's like you reach a threshold, you start to be able to do something, then that works, and then you build that capability into a bunch of systems and it becomes useful. But it's not as if that capability itself, just because it made that one jump doesn't mean it's going to make lots of other jumps.
It's interesting you say that because most people that are playing around with what the consumer version of what they think AI is from ChatGPT or Gemini, people would think that there's been like people think this is pretty much AI. Like this is the last 2 3 years. People just think AI just kind of popped out of nowhere, right? Like from 2021. Before that, AI didn't even exist. Like it just started come because now they can play around with it. You mentioned that it kind of there was a tipping point of from the image recognition perspective. So what was the difference between what was it that made people see and feel the new revolution of AI in the last couple of years? What was the
Right.
segment
Well,
particularly
so,
that
okay,
improved?
this is a very shaggy story. It's a long story. You asked, what's the history of this? It's quite a long, complicated story. I mean, the it
For
okay.
sure, yeah.
So the big thing that happened at the end of 2022 was ChatGPT and the idea that you could get a neural net to write text based on a prompt. That had a long history. That has a history going back into the 1960s, even into the 1950s. People had, well, okay, there's a couple of branches here. I can let me explain the well, yeah, right. No,
You can summarize it also
I
if
think
it
it's
gets
kind
a
of
bit long.
interesting. Perhaps people will find it. I'm not sure this history is well told
People,
actually. But
yeah,
the
go. You can
I mean,
go
so
through the whole thing.
let's talk about a couple of branches. Um, I, well, there's a branch that I was involved in. There's a branch I wasn't involved in. The branch that I was involved in was this thing that I've been interested in doing since before 1980 or so, of can one answer questions about the world from the knowledge that we've accumulated in the world? And I had made some sort of science advances that made me convinced that there wasn't sort of a bright line difference between intelligence and mere computation. And so it's like, well, if I'm right about that sort of almost philosophical claim, it should be the case that we can build a system that does this kind of answering of questions based on the knowledge that our civilization has accumulated. So in the mid-aughts, I decided, okay, it's time to actually try and do this. And so that led to this system that came out in 2009 called Wolfram Alpha. And Wolfram Alpha is kind of, the idea is to take pure natural language, turn it into a precise computational language, then be able to compute answers from that and tell them to people. And when we were introducing Wolfram Alpha, it was sort of interesting because AI was absolutely dead at the time. Everybody thought nothing like this is going to work. People had tried to make question answering systems with various kinds of AI techniques, statistical, symbolic, whatever. They tried to do that for decades. It had never worked. It was kind of particularly notable. I mean, to tell a sort of story that indicates what was happening. It was a couple of weeks before we released Wolfram Alpha. I happened to see Marvin Minsky, who I mentioned earlier, who was sort of a big AI pioneer. And so I say to Marvin, we got this cool new thing that's coming out. Let me show it to you. So I kind of show him a couple of things, and he's like, changes the subject, not interested. It's like, because for him, he'd seen a zillion examples of people saying, I built a question answering system. And so I said, look, Marvin, you should look more carefully. This time it actually works. And so he types a few more things, and then he's like, oh my God, it actually works. And he's running around this event that we were at, telling people, you've got to see this, you've got to see this, it actually works. It was interesting because it was a time when, as I say, that was kind of a snapshot of the fact that at the time people just thought AI was dead in 2009, and it was that was and so with Wolfram Alpha we kind of for the first time sort of solved the natural language understanding problem of taking kind of plain text. And people had sort of thought, well, just make a computer understand that. But it wasn't clear what it meant to make a computer understand it. I only realized this sort of after we'd built what we built. We had this huge advantage because we already had this underlying computational language that we built came out in 1988, Mathematica, and what's now Wolfram language, which is this kind of way of representing things in the world computationally. We already had that kind of precise computational representation of the world. And so our natural language understanding wasn't just abstractly get the computer to understand this. It was translate what those pesky humans say into this precise computational language that we can then do computations with. So that was kind of one piece of that story. Now, the next thing is sort of what was the tradition that ChatGPT came out of? It's a very different tradition, very different kind of line of work. Kind of started, I guess, in the 1940s when people were doing cryptanalysis in World War II. And the question was, when you do cryptanalysis, when you encrypt a message, you're turning it from meaningful English letters or an English sequence of English letters to something where the letters look completely random. What you have to do to fish out the English is to sort of statistically figure out what was done. And so the sort of critical idea was, well, English isn't just a random sequence of letters. English has certain statistical regularities. Like if you see a Q, there's going to be a U next, probably. You see more E's than you see, X's and so on. Okay, so a chap called Claude Shannon worked out this thing he called information theory. It actually worked out, I think, during the war. Probably Alan Turing was somewhat involved in this also. Wrote this paper in 1948, I think, introducing information theory and this idea of sort of the statistics of things like language. So given that you had the statistics of language, you knew which letters were more common, which pairs of letters were more common, and so on, you could start imagining generating language statistically. You say, okay, if you happen to randomly pick a Q, the next letter is going to be a U, et cetera, et cetera, et cetera. So that was kind of a way of thinking about language. And so the thought immediately came, well, maybe we can get language, we can just generate language statistically and it'll be meaningful. Well, it didn't work out that way. There was a whole sequence of efforts. It was particularly of interest people doing speech recognition, where you're trying to figure out, we hear these speech sounds and we can sort of statistically work out, oh, that speech sound is roughly a vowel. But then the question was, well, how would you assemble those sort of somewhat imperfect things about, well, that might have been an L, that might have been an R, whatever else. How would you assemble those rather imperfect kind of guesses about what those phonemes, what those fragments of speech were like, into something which could actually be a meaningful piece of text? And so people were very interested in kind of the statistical structure of text to be able to do those kinds of things. So that became sort of a whole area. Well, what happened in the, what was it, by the around maybe the early 2010s, was people had done, there were speech recognition systems that worked by taking speech, breaking it down into phonemes, different speech sounds, recognizing particular patterns of phonemes and so on, trying to do the statistical reconstruction of language. It was a big sort of painful process. People started just trying to use neural nets to just go straight from the audio you hear to the text that's being generated. And turns out it worked. And so just as image recognition got solved, so kind of speech to text kind of got solved too. And that was, by 2010, when Siri came into the world, and we were kind of the computational back end for Siri, and it had a kind of voice recognition system at the front end. And we were constantly frustrated because it would send, whenever people were asking about math and, pi in math, the voice to text system was sending PIE as the word that they were saying. But that got solved. It was so that was sort of the next big success of neural nets. Then there was the question of, could you do what was called sequence prediction? Could you do a better job of knowing, given that you have a piece of text that starts this way, what will come next? And what existed, even in like 2021, times like that, of sequence prediction was really cruddy. It really didn't work well at all. We tried to use it a bunch for doing things like predicting pieces of code for autocompletes, things like this. Really did not work well. And then, the guys at OpenAI basically collected this huge collected this huge amount of training data. There was one kind of technical idea, which I'm not sure how significant it will be in the long view of history, this idea of transformer nets. The question is, if you look at a slice of brain, so to speak, I'm too squeamish to actually do that in real life, but you'll see that the neurons are all sort of very randomly connected to each other. It's as if every neuron is more or less connected to every other. But there are areas like on the retina, for example, where in the retina it's photoreceptors, but then in the visual cortex it's actual neurons, where things are connected more locally. If you're dealing with an image, the image has all its pixels kind of laid out in 2 dimensions, and you want to kind of have your neurons kind of laid out in 2 dimensions as well. That led to so-called convolutional neural nets, which are the things that were used for this image identification problem. When it comes to things like language has the feature that it's sequential. It's just this stream of letters or words or sounds or whatever coming out. And there were these things called transformer nets, which are networks that are that only have connections sequentially, but their connections can be quite long range, just as a word somewhere in a sentence can kind of refer back to a word that's much earlier in the sentence. So anyway, big sort of training effort was done using a lot of material from the web and elsewhere.
Didn't they take it from Google as well? Didn't Google have some open source information out there that OpenAI used for their initial algorithm?
I don't know. Google had been, when the original kind of image identification thing was done, Google had swooped in and sort of bought the company that was created overnight, so to speak, by the academic researchers who'd been working on that. So Google had sort of developed that, and I think we're using it quite a bit for search, because when you're ranking, it's always this problem of how do you rank the pages that come out of a search, what's the most relevant and so on. And there are many different signals you can use, and figuring out how to combine those signals is something that's a pretty good case for using neural nets. And I think they were using neural nets for a while for doing that. And that was, but yes, there had been, I mean, really, there was quite a lot of excitement about neural nets going to be able to do things, but it wasn't clear what they were going to be able to do. And, when ChatGPT sort of arrived, I remember chatting with the folks who worked on it just after it came out, and sort of my obvious question was, did you know it was going to work? They were like, no. And in fact, probably had they known it was going to work as well as it did, they would have tried to constrain it in a lot more ways than they did. And a lot of things they did were kind of sort of what you do if you're just trying to do the experiment, not what you do if you're trying to build a production system.
Just to see if it works.
So then the big surprise was that it worked.
Yeah.
I mean, I kind of liken it to sort of a history of technology thing, which was the invention of the telephone. People had known that in principle, you could transmit voice you could transmit sounds over electrical wires. But when people had done that, you would try and listen at one end of the wire and you wouldn't understand anything that was being said. And eventually, Alexander Graham Bell found a bunch of hacks that, again, I don't think he knew were going to work, but suddenly people could actually understand what was being said. I don't think it sounded very good, but it was good enough that people could understand it. And I think the same kind of thing happened with neural nets. It got good enough that it was like you could read the text and it read like, meaningful text that a human might write. And that was sort of the ChatGPT moment where kind of the being able to generate meaningful text, being able to kind of start from a prompt, if on the web, it was like this question was asked, this was the answer given, you could expect it to sort of statistically follow that. Now, there was an additional trick, which was this idea of reinforcement learning, and particularly reinforcement learning with human feedback, which went beyond just how would the sentence continue. The cat sat on what's the next word? Statistically, from the web, it's probably Matt, et cetera, et cetera, et cetera. But the idea of get the thing to actually do what it's told and do things like answer questions, that was a thing that was sort of another layer of training that was done, and it worked out. And I was when ChatGPT came out, so many people were asking me, how does this work? Why is this working, et cetera, et cetera, et cetera. So I eventually wrote what turned into a little book about what is it called? What is ChatGPT doing and why does it work? Which became very popular. It was kind of, in a sense, disappointing for me because it took me a week to write. And there are lots of other things I've written that took me, years to write. And the one that took me a week to write, people seem to like very much. It's now translated into lots of languages and things. I don't know whether done by humans or AIs. I'm not sure. But anyway, it's always fun to see the book covers from different countries and so on. But the thing I kind of, the two things that sort of came out of that, one was, why does it actually work? And the other was, how does it sort of fit into the ecosystem of the world? The why does it work question, the thing I realized is that, in a sense, the reason it works and the thing that surprises us so much is a little bit like the thing with the tanks in the daylight or not. There's something about language that we hadn't noticed that actually is more regular than we had imagined. And we're all used to the idea that we do grammar, and we know that in English sentences are formed with noun, verb, noun, with different parts of speech and different combinations. But there's more to it. Most sentences that are just noun, verb, noun are completely meaningless. But there's a kind of semantic grammar, a grammar that's based on meaning that says what noun, what verb, what noun can go together. And there's I think, a lot of regularity in that structure. There's a kind of a semantic grammar of language that is effectively what ChatGPT discovered statistically by looking at the web. And people were very surprised that, for example, it could discover logic, that it could make arguments that were made logical sense. I think the way it did that is the same way that Aristotle discovered logic back a couple of thousand years ago, which was you just look at a bunch of sentences that people say and you ask what is the kind of structural pattern that they have, led to syllogisms in Aristotle's time. Somewhere the statistical knowledge that ChatGPT has is of things like syllogisms, and that is okay. So it's able to produce something that is logical, just like it can produce that the next word after the cat sat on the is Matt. But it's kind of learnt sort of the semantic grammar of language, which includes things like logic. So the thing that was very clear was that ChatGPT good at generating text. What it was also good at generating. Well, one of the things that we had from Wolfram Alpha was a system that could take text and compute from it. So that was a pretty nice combination, because you can take the things that ChatGPT is producing as text, which includes ChatGPT making up a question that it wants to get answered. And the thing we realized, well, very immediately actually, was that you could use English effectively as the transport layer between the AI and our computational system. And you could have ChatGPT kind of call Wolfram Alpha as a tool. One of the surprises early on was that not only could it do that using English as a transport layer, also our Wolfram language, which I've been building for so many years and lots of people use as a language for doing computation, as a way to represent kind of one's thinking computationally. Well, ChatGPT could do the same thing. It can write Wolfram language code. And so we built, at first it was kind of a plug-in to ChatGPT, and then lots and lots of other things where kind of the picture is what the LLM, what the large language model is doing is, by the way, maybe a historical point that perhaps is of interest is, why are they called large language models? Well, it's because there were also language models, which were the things that people used to try and figure out, what would the next word be statistically to be able to disentangle speech to text and so on. So there'd been a long tradition of language models, often so-called Markov models, where you essentially have these different states and you're going from, several different sort of states of a system, deciding what the next letter will be. So large language models were like, let's do this with neural nets and put billions of neural net weights in there. That's a large language model. So LLMs, large language models, of which ChatGPT is an example. There are now many, many others. We have a nice little website where we every week do a kind of a rating of how these various LLMs are doing. And it's kind of remarkable. It's an active enough field that practically every week there are changes at the top, so to speak, in terms of what the winning LLM is this particular week. But it's the thing that sort of has emerged is that LLMs are really good at doing this kind of linguistic interface, at dealing with things, language, sort of for language's sake. They're not good at doing things which require computation. That's not what they're intended for. That's not what their structure is. It's actually, we have a big clue that they're not going to be good at that, because humans aren't good at that either. We don't get to be able to do, run programs in our minds and things like this. And so it's been nice for us because, I just spent 4 decades building kind of this whole system for being able to do broad kinds of computations about the world. I mean, programming languages are intended as a way to kind of take what computers can do and give humans a way to sort of tell the computer in its terms what to do. What I've been building for a long time is this kind of computational language which tries to describe the world computationally, where the world could be, cities or movies or images or geography or whatever else, and be able to represent the world computationally so that one can compute about it. And that's something where it's sort of a higher level thing than has been attempted with programming languages. This has been, I use the system we built all the time, so do a few million other people. mostly for research and development and those kinds of things. Although there are an increasing number of kind of practical systems in the world that use our tech underneath. It's always so strange when you've built a bunch of tech and then you are a consumer user of some big system in the world, and you know that your tech is underneath it, but it doesn't do you any good. Still, the consumer system does what it does. But in any case, the thing that uh, it's been interesting for us because there's been sort of this. We used to have human users primarily. Now we also have AI users, where LLMs are interfacing with humans through natural language, but underneath they're doing these computational things using our tools. As It's been an interesting thing to watch that happen, and it's something where what LLMs kind of are readily able to do is quite different from what you can readily do with sort of raw computation. The combination is really powerful, and that combination, one of the things that will eventually happen, although I don't yet know how to do it, is to make a more sort of fine-grained integration of those things. Because right now, the LLM is going along, it's generating a bunch of text, then it generates kind of the things it needs to call our system as a tool, gets the results back, then keeps going and takes those results and sort of weaves them into the text that it's writing.
What's the gap then from what we have right now with what people are now coining, AGI, artificial general intelligence? What is the technological gap between what we have to, and first, actually, maybe define what AGI means for you before we do that, and then what is the gap that we have from where we are today to what we need to be, where we need to be to get to AGI, and what is that going to look like for the consumer's perspective? Because most people don't really know the technical details, I guess.
Nobody knows what AGI really means. It's a buzzword that it's kind of like first AI was a buzzword and people didn't quite know what that meant, except they thought it meant things that do stuff that's kind of like what people do. And it's like, well, now we've got things that do lots of stuff that people do, whether it's being able to generate language, drive cars, whatever else. Um, but still, there's got to be something else that people do, and that must be AGI, some general intelligence thing. It's kind of ironic that actually, I just realized this as I'm talking to you, that the term general intelligence was, I think, coined in the 1930s, and it came in when at the same time as the concept of IQ came in, in my opinion, a very troublesome concept. But it was at a time when people were trying to figure out, I don't know, for recruits for the army and things like this. It's like, was there a way? Just like you could say this person is, 5'9" tall. It's, let's give a number. Let's give a metric to, quotes, how smart are they? In my opinion, a rather doomed concept. But that led to this thing called G, the coefficient of general intelligence. And then people started making tests. So I think that's where this comes from, which is a very doomed kind of place. But anyway, but what does it mean? And what, there are, the thing is that you have to define, what do humans do? How do we make something that does more of what humans do? And one of the things that's difficult there is if you say, well, do I have an AI that can pick something up with its hand? Okay, that's a human-like thing. Do I have an AI that can have an emotional response? That's a human-like thing. Do I have an AI that has all of these other? Do I have an AI that feels its own mortality? All these things. In the end, the only thing that is going to check all the boxes for being like a human is a human. So, you'll be able to check more boxes. The thing that's the box of electronics sitting on your desk, it's going to have certain things that can be human-like, but other things that won't be. And in the end, if you say, well, what we mean by AGI is something that's human-like in all respects, that's kind of a doomed idea, because the only thing that's going to be human-like in all respects is a human. So now the question is, well, what happens? What does it look like as we go in the trajectory that we're going on so far of, we've got these neural nets, they've got billions of weights in them, they've got millions of neurons, they've got, what happens when we make that bigger, for example. And we have kind of a model of that, which is a little bit kind of strange to think about, which is, you start off with, I don't know, a fruit fly, for example. It has 130,000 neurons in its brain. We have about 100 billion neurons in our brains. Cats and dogs have, I don't know how many, maybe a billion or so neurons in their brains. Well, we get to do some stuff. We get to do a whole bunch of stuff that fruit flies don't get to do. And in particular, one of the ones we're proud of is human language. That's one of the things that sort of made our civilization possible, and so on. And, cats and dogs don't quite have that. They maybe have, sit, fetch, and so on, but they don't have the sort of compositional language that we have, being able to put words together in arbitrary combinations to make sentences and so on. And so a reasonable question to ask is, well, if we're going in the trajectory we're going, and we've got these neural nets that have, human brain-ish numbers of neurons and so on, what would happen if there were even more than that? What is the next step from cats and dogs to humans to the next level of minds? What does that look like? And that's kind of a thing that you might wonder, sort of, we've got something that is human-like at some level right now. We can go on checking the boxes of giving it, letting it be, my guess is within, the next big thing that will get solved in AI is robotics. And, it's been super difficult to get, robot hands to pick things up and, be able to pack boxes with whatever stuff you want from a warehouse, things like this. It's something we humans managed to do fairly easily. It's something that it's been a little difficult to get training data, for the stuff that humans write. Well, there's, a trillion words on the web and things like this. It's a little hard to get information. You can watch videos and things like that to see what, how one manipulates things in the world. I don't know exactly how that's going to work out, but my guess is that will be another thing that people will be like, oh my gosh, this can now be done, with AI, and that will have a whole bunch of consequences for practical things that are possible in the world. But that's sort of a different story.
But is that AGI, or is that just AI in a different form, in a physical form through hardware?
I mean, the only thing
Right.
that's what is the limit of AI? What I'm saying is the limit of AI, if you define intelligence to be the thing that humans have, is pretty much humans. Now the question is, if you're going that trajectory, sort of technologically, can you zoom right past the humans? Can you get to something that is sort of the greater, I don't know whether we call it intelligence, but the greater capability than humans have? And I think the answer is, well, yes. But then the question is, well, okay, what is that like? When, if we have a thing that is computing much more than humans compute, we have 100 billion neurons, we have a thing with 100 trillion neurons, we have something that's doing not the number of computations that we do in our brains every second, but zillions of times more than that. What is that like? Well, the fundamental thing is it's not very human-like. And we have a really good model for what it's like, which is the natural world. The natural world is absolutely full of things that compute much faster than brains compute. That, you look at any kind of, babbling brook or something like this, all that fluid turbulence and so on that's happening in the water, that you can think of as computation, just like the electrical signals in our brains we can think of as computations. There's lots of computation going on in the babbling brook. It's computation that isn't very human-like. It's not the same kind of thing as happens in brains, but it's a lot of computation. And so I think one of the things that one sees is that, it's getting more computation is something that one can readily expect. It's in fact one of the things I've done in science for a long time. One of sort of my big discoveries and directions in science is to understand what computation in the wild looks like. When we do computation, usually we write programs, we set up programs to do particular things that we want to do, so to speak. But a question that I got interested in the beginning of the 1980s was, what does a program that you just pick at random, what does it typically do? You might assume if it's a tiny little program that it would just do tiny little simple things. The huge surprise that took me a while to kind of really get used to is that's just not true. In the computational universe of possible programs, even very simple programs can do incredibly complicated things. And I sort of realized that from a science point of view, that's kind of the secret that nature uses to make all this complexity we see in nature. But it's also something that is, in a sense, it's sort of computation. It's even what you might think of as intelligence, but happening in a very non-human way. It's it's just there is a lot going on. You can look at these things, you can say, wow, that's really complex and intricate and interesting, but I don't really understand it. I mean, we can think of science, in fact, the mission of science, in a sense, is to take what exists in the natural world and kind of make a bridge between that and what we can understand with our finite minds. I mean, it's like saying, oh, we're not going to, in our minds, we're not going to understand what every molecule in the river does, for example, but we can say we roughly can talk about certain laws of fluid mechanics that govern roughly what the river does. We're making a bridge between what's actually happening in nature and what fits in our finite minds. So now we have this picture
Yeah.
of what's
Yes.
happening the I'm realizing your podcast is called Growth Minds, and I think this is a highly appropriate topic for the question of what higher minds are like. Seems like a highly appropriate topic for your podcast.
Yes.
Yeah,
Hence
yeah,
the
right.
hence the
Well, but
conversation
this
with you.
particularly this notion of what does the greater mind kind of look like, and there's this sort of question of what if we put in more neurons, if we make a bigger mind, so to speak, what kind of thing will it be like? And I think the thing we have to realize is it will be very non-human. And the question of whether it will, it may be that it does all these things that we could try and make a bridge from what it does to what we understand. And we could say, wow, we're very impressed. That's scientifically interesting. But it's like what it's doing is it's not like a human just, you know, running, there'll be some things where it will be a human running faster. But mostly, I think it will be things that are extremely non human. And where the real question is, how do we take that non-human computation and kind of lasso it into something that we care about? It's very analogous.
Yes. So the definition of AGI of people saying AI reaching human intelligence or human level intelligence, do you find that's like the wrong way of even looking at the progression of AI? Because AI is heading towards a place where it'll actually be the like very non-human intelligence from what you're saying. It'll just transcend it.
When I first started paying attention to AI, late 1970s, there was this kind of checklist of things. When one has this, we will have AI. Like one of the things was being able to do symbolic mathematics. Another was being able to do question answering. Okay. You go down the checklist, we've got those things. But still people say, but there's something different about humans. Well, yes, there's something different about humans. Humans are humans and they eat and drink and die and those kinds of things. It's different from what this electronic device, software system, whatever does. And so, people, I mean, throughout history, people have kind of wanted to search for what is so incredibly special about us humans that is sort of fundamentally special, not special in the particulars of we are humans that happen to be the way we are, but something where we're sort of on some chart that you could make. We're this data point that's just way out abstractly. And I don't think that, I mean, the lesson of the history of science has been we keep on getting humbled in the fact that no, we're not special in that way or this way or whatever. And I think the way in which we're special is that we are precisely the way we are, so to speak. We have all the particulars that we have of, two eyes and ears and all this kind of thing. We are the particular thing that we are. And yes, you can make sort of an AI that that more and more closely approximates the particular thing we are. The humanoid robot that has, its experience of the world is similar to ours because it's walking around the same way we are. The thing with two eyes that has a similar experience. If we had a thing with a million eyes that was seeing all kinds of things from everywhere around the world, that wouldn't be a very human-like experience. The kinds of things that the million-eyed AI would kind of think were useful to think about are probably very different from the ones we would think were useful to think about.
Yeah, it's interesting that there's so much fear brewing around society, around how AI is going to be replacing humans. Yet we keep putting this goalpost up of trying to see how much we can replicate what AI is with human characteristics, as if like we are actually trying to
Well,
replace ourselves. Yet there's fear
well,
brewing
I
at the
think
same
that,
time. It's kind
at
of ironic.
least if one is saying, what's our technological objective? Oh, it's to make this thing that's human-like. That's a goalpost you can see type thing.
But that's the wrong goalpost, you're saying. If the whole idea of us, fear brewing that AI is going to replace us, shouldn't we try to make sure that humans exist as our individual selves and make AI this completely different thing that can help us rather than trying to create human level intelligence where we will actually just be
We are negligible
negligible?
relative to nature, but we seem to have just a fine time in that position.
Mm.
Relative to the
Yeah.
universe, we are negligible. Relative to even the computation that happens, around us on the Earth, we're negligible. Yet we feel pretty pleased with ourselves, regardless. And I think that's the way to think about it. Is that
Mm.
it's like you could, you could, we exist in a certain niche. That is the one that is the human niche. And we can say, well, gosh, we'd like to be, on other planets. We'd like to be this, that, and the other. It doesn't, it's still the case that the niche we care the most about is this human niche. Now, you could say abstractly for the universe, it's more significant to the universe if our AIs are running around, going to other stars or whatever else. I don't know what it means to say it's more significant for the universe because that's not like there's an abstract definition of, you're kind of asking for the ethics of the universe, which is something that doesn't really have a definition. These kinds of questions of what's it significant for, what's it meaningful for, what's it kind of right for, those are questions which in the end, they're anchored in us. You can't ask those questions abstractly in a meaningful way. I mean, I think that so this, one of the things to realize is, what is technology? Technology is an attempt to take what exists in the world and kind of take pieces of it that we can use for human purposes. And, different kinds of things, when people discovered magnetic rocks, I don't think they knew what they were good for at the beginning. When people discovered liquid crystals, they certainly didn't know what they were good for at the beginning. And then it was realized, well, you can make a display out of liquid crystals, and that was a use case for that. And so similarly, there's sort of a vast there's all this stuff in the computational universe, all of this computation in the wild. Most of it, we don't know how to use it for anything that we humans care about. What happens in the progress of science and technology and society is that there starts to be, we gradually get to have more and more things that we think we care about, and we probably forget about other ones that we don't care about anymore. I mean, there are lots of things where people would say, I can't imagine that, you could make a living, playing video games, streaming video games or something. It's a thing where, or even, it's I can't imagine people will find it interesting to do this thing that's a little video game or something. There are these things that that happen that cause us to decide there is a purpose to that. I mean, if we look at what we do today and we imagine it from a 1,000-year ago lens, a lot of what we do today would seem absolutely pointless to somebody from 1,000 years ago. I mean, I think one of my favorite examples of that is, walking on a treadmill. Explain to somebody from 1,000 years ago why you walk on a treadmill. Well, it's to improve my health, so I'll live longer, so this, so that. It's like, why does that make any sense? we do what we do for the greater glory of God or whatever, and we are, this is our sort of brief time on earth type thing. And why are you? There are many, you could look at different things that people might have thought were significant 1,000 years ago, none of which would explain why you would walk on a treadmill, why you walking and not getting anywhere type thing. And I think that's something you see in the progress of society and civilization, is you see sort of the things that seem purposeful and meaningful gradually change. And the thing, and what does AI or automation in general do? It takes the things that humans want to do, and it somehow makes them easier to do. And the thing that you might say was that maybe there'll be no need for the humans because everything's going to be easy. But then you still have the question, well, what do you actually want to do? And that's something where there's no AI that's going to answer that question, because there is no answer. There's no abstract answer to the question of what should you do? What should the universe do? The universe does what the universe does. It doesn't, there's this choice of what to do is something that is sort of the ultimately quintessentially human thing, because there are many things you could do, and it's up to, well, you could pick, it could be cats and dogs that we're deciding too, or it could be aliens that we're deciding, but some arbitrary thing has to decide what it is that you want to do. So, I mean, I think the way I see it, the sort of the future of, well, the sort of arc of technology has always been to take things humans want to do and make them more automatic, easier to do. And so what does that do for the humans? Well, I looked a while ago at what's happened to jobs that humans do. Like in the US, for example, there's data back to like 1850 or so of what jobs do people do. Back in 1850, most people were doing agriculture. Most people were actually, plowing fields and things like this. That almost all got automated. So then what happened to the economy? Well, what happened is that what was a big chunk of the pie fragmented into a zillion different areas. And you see that typically as economies get more advanced, there are more different categories of jobs that develop. And that's sort of typically the pattern of, some category of thing was hard to do. A lot of people were just on the ground doing it. Then we automated it. Then that very process of automation opened up lots of other things that were possible. And, it was, and that then, was that then people found things to do that in the end, the front line usually ends up being things people have to make choices about. That's places where you can't feed in. There's no abstract way to feed that in. Now, you can be in a situation where people say, well, let's just abdicate those choices to the AIs. That's kind of a bad situation, because then, in a sense, you're saying, let's just take society and civilization as it has been, as captured by the AIs, and let's just run the same thing over and over and over again. It's kind of the humans never get to sort of do anything that is kind of new and different. Now, then you ask the question, well, why can't the AIs be creative? It's very trivial for an AI to be creative. It just has to pick a random number, and that's doing something that is creative. Now, the question is the random thing that it picks, is that something a human will care about? An interesting question that's kind of a frontier question right now is, for example, something I've looked at quite a bit, is if you look at mathematical theorems, it's pretty easy to get a computational system to just go spewing out zillions and zillions of theorems, billions of theorems. They're all true theorems. You might say, wow, that's exciting. That's making progress in math. But it's not making progress in math that people care about, because most of those theorems, people look at them and say, okay, I guess it's true, but so what? And what counts as kind of math that humans care about tends to be this kind of prong that gets built, this tower that gets built. Humans care about this. Okay, given that they care about that, now they care about this. And you're kind of building it up that way. It's the same kind of thing. Well, you see it all over the place. I mean, I did a thing a year or so ago. I was curious about sort of alien minds and the mental imagery of alien minds. So what does that mean? So the You can get an image generation AI system. You tell it a description, a cat in a party hat. It will generate a picture. It will generate zillions of pictures that are all would match the description, a cat in a party hat. Okay, so that's what the AI would do, having learnt from humans who've labeled their pictures and so on. So now you ask the question, well, what if you take if you modify the innards of the AI, or alternatively, if you take kind of the internal description that it has of cat in a party hat and you start tweaking that? Well, you move away from the concept of cat in a party hat into what I was calling interconcept space. You move away from these human-defined concepts to concepts which exist in the mind of the AI, but are not familiar to us humans. And what you see, I was referring to it as Cat Island. You see this kind of island in that interconcept space that is around the cat concept. We humans recognize that as those are pictures of cats. Then you move off into this interconcept space, which is a space that is kind of, in a sense, just as meaningful to the AI mind as the cat point in interconcept space, but it's not very meaningful to us. You look at these pictures and it's like, I don't know, it's a picture with a bunch of stripes and dots and squares and circles and this and that. I don't know what it's of. I don't know why I care about it. But you also got to realize that some of those pictures, actually, I was amused to see that somebody took some of the pictures that I made in that post, and they're now in some art exhibit somewhere in Paris. So that style of making pictures is now, at least in one minor case, I think actually there have been some others of this as well, but considered as art. So what was something in interconcept space might one day develop into the such and such style of art that then we would know about, and then it becomes a concept that's part of sort of the concept space for us humans. So the thing to realize there is that the AIs are frolicking around into concept space, so to speak. What happens inside an AI is full of these things from interconcept space. They're just extremely non-human, just like nature is doing lots of non-human stuff. And the question of whether, it's if we open up an AI as it exists today and we say, what's going on inside here? This is something I've done a bunch of work on recently, actually. It is interesting because it is essentially, there are these kind of lumps of irreducible computation that you find there. And what's happened in the training of the AI is it's kind of fitted together these lumps of irreducible computation to do the things we want it to do. Kind of the analogy I've been using is it's kind of like it's building a wall out of rocks. It's building a stone wall, so to speak. It's taking these lumps of computation that sort of happen to fit in and more or less correspond to the thing you need to tell cats from dogs or whatever. And it's putting a bunch of those together so that you get something that is that achieves the objective we want, like distinguish cats from dogs. What's happening inside is something that in some ways is sort of randomly picked because it's which rock happened to be lying around. In some ways, it's incomprehensible because it's full of these kind of lumps of irreducible computation. And, you can say, well, gosh, what will the world be like when it's dominated by AIs that are doing these things that are incomprehensible to humans? I think that feeling is very much like the feeling of living in the natural world. I mean, there's been this brief period in history where the technology we build, we expect to be able to understand. In the past, when people were, getting transported around by riding horses, you could know something about how to get the horse to do what you want, but knowing how the horse works inside was not something you really cared about. You were able to use the horse for something that was useful to you, but you didn't know mechanistically how the horse worked inside. Post-industrial revolution, for a brief time, we've been operating machines that are simple enough that we know what's going on inside. We're now back to a situation where to make systems that can really make use of computation as it can best be made use of, we sort of inevitably have to deal with this kind of irreducible computation that we can't readily understand with our minds. We can't have a kind of narrative explanation of what's happening inside. So now the question is, well, how do you deal with that? Well, it's the same thing that we've done with technology forever and ever, which is there are things that are in principle possible, that might be possible in the natural world, that might be possible in the computational world. Now, how do we use those for things that align with the things we care about? And some part of what will happen will be stuff we don't understand that doesn't align with what we want. I mean, in the natural world, there are tornadoes and things that don't align with what we want. We end up, being able to predict them and, having tornado shelters and things like that to kind of exist alongside them. And no doubt there will be things like that that come out of the computational universe, so to speak. Perhaps in some sense there already are. And it's, I think that's the view of what, sort of how to conceptualize what it's like to kind of coexist with something which you could think of as a greater intelligence, I suppose. It's certainly greater computationally, but that's something extremely familiar from the natural world.
As someone that has a very high level of intelligence that probably understands things that most people don't really at a deep level, even with AI and how it's evolved, you have a very good understanding of it. Do you fear a world of AI involvement that exists
Well,
where
I'm
you
used
don't
to not
understand?
understanding.
Do you fear that world?
I make these little tiny programs where I look at the program and it's totally trivial, and then I run it, and it does things that I don't understand. I mean, I've lived that myself for 45 years or so. So at the beginning, that was very bizarre. It was very much like, this can't be happening. It can't be that this tiny little program makes all this amazing stuff. But, you kind of, that's the way nature is. That's one sort of gets used to it. Now, for me, my general approach to things is use any tool you can. And so, for me, one of the things that's funny, I was just realizing this actually, people are kind of sort of say, well, if the AIs get to be really smart, they'll, what will that be like for humans, so to speak? I myself happen to have been in this situation that I've sort of created for myself where I've been building tools to sort of that can enhance my ability to think about things. I've been building such tools for I don't know, 45 years or so. And so, the tools I built allow me to take ideas I have and sort of see their consequences really pretty efficiently. I mean, I can see that if, once I have an idea, once I know what direction I want to go in, it's like type, and I'll have a little Wolfram language program and I'll run it and it'll sort of let me work out that idea. It's a very short process. It's actually got even shorter recently because we built this notebook assistant system that is based on LLMs and other technology that we made, that allows one to kind of even more efficiently go from kind of a thought you have to computational language code that can actually run. So it's a funny thing because I guess I've lived this perhaps ahead of where other people would have lived it, although there are plenty of people who use our tech who probably are in a similar position to mine, where it's like you have an idea, you want to see its consequences. That's a very short path. It's something where normally, if you didn't have, I've been building technology partly for myself, partly for everybody else, that really shortens that path. It really automates the going from idea to reality, at least for things that you can implement on a computer. It's not, building rockets and things like that. It's just doing the kinds of things that I'm interested in from an intellectual point of view. But so, that's a sort of this thing about you imagine it and then you make it real. That's a thing I've been living for a long time. I think people will increasingly come to expect that. And that's not sort of a dehumanizing thing. In a sense, it's a human amplifying thing, because what gets more important is, well, what is it you want to do? What's the idea that you have? And I think that the question of, well, how does it work inside? I mean, that ship sailed a long time ago. I mean, people, who understands what in detail is going on inside their computer? Even, as I say, when I do science and set up these simple programs, they're always doing things I don't understand. Always. I mean, when I'm working on those kinds of things, practically every day, I'll be sort of humbled by the fact that I imagine what the thing is going to do, and then it does something I didn't imagine.
Right. How do you answer that though, from like a maybe like more of a nihilistic or doomsday level questioning? You mentioned nature doesn't always, we don't understand nature, but nature can certainly kill us. How do you think about that question when you mentioned not understanding how things are going to how things are going to react from a software perspective, but as we get into hardware and robotics, things that can physically hurt us, do you what are your thoughts around that as we become less necessary perhaps
Look, there are
for
plenty of
AI and their
self-driving
perspective?
vehicles right now, planes, trains, some cars, things like that. There's plenty of, we have sort of given over to various levels of AI, many kinds of things. We've, it's again that this question of sort of, we perhaps humanize, we say, well, maybe there'll be this kind of AI that rises up and wants to kill us all. That's a very complicated concept because, I mean, look, I think from a practical point of view, there are stupid things that one could set up to abdicate to AI. One could connect AIs to lots of systems in the world and just sort of and say, oh, everything's going to be fine, and it won't be. But I don't think that's. I mean, one thing to realize is it's not like there's one AI in the world. There could have been that there was in science fiction and in even people's early conception of computers. It could have been we just build this one giant computer and that's all there is. That's a little bit of a different situation. It will be like saying there's if there was one organism and there was no competition between organisms and so on, it would be a different situation. I don't think that so we're not in the one big AI situation. So now the question is, what people imagine things like. I mean, I don't know. To my mind, I'm not a big. People say things like, well, think about the IQ of an AI, and think about the fact that it can improve itself, and its IQ is going to run off to infinity. Well, I think of many people who would be able to do IQ tests really well, who I know, who I can be quite sure are not, that on its own doesn't, it isn't the ticket to sort of, take over the world type thing. I think that the thing, I mean, there are many features of the world that are, there are many physical constraints in the world. Yes, you can have an AI that's figured out all kinds of things, but it's still subject to the laws of physics. It's still, there's things where people might think, oh, it's going to figure everything out. Well, actually, you have to try a bunch of things. The physical world is partly because it is doing all this computation. You can't figure out in advance things about what's going to happen in the physical world. You actually have to try experiments and so on to see what's going to happen. That's another piece that sort of slows down it's just going to figure everything out and take over. But I think the most significant thing is that there is a people tend to project onto AIs the idea that the AI is going to want to do this or that thing. But just as they project onto other people that other people are going to want to do this or that thing, the only thing we ever know for sure ourselves is how we're feeling internally ourselves. Everything else is kind of an assumption, a projection. And the concept that, the AI that has all of this sort of computational ability is going to want to do something is a very weird concept. I mean, the generalization of wanting to, for example, all these programs that I've studied in the computational universe, I might, as a human, say, oh, it seems like it wants to, fill this thing with black squares or something. But that's really a very weird description. It's a very humanized description of something that really isn't very human. I mean, I think that this question, I was having a conversation with person who's kind of one of the leading AI doom folk, chap called Eliezer Yudkowsky.
Is that
The
okay?
We had a long conversation, and I think I finally understood his view of kind of the scenario of doom. And honestly, as I said, I just don't think it's right. I mean, his theory is this. His theory is AIs will be able to optimize the doing of almost anything. I agree with that. Up to the constraints of the physical world. In other words, if there is a thing you can define that you want to do, to be able to do it, one will be able to optimize the path to be able to do it. I mean, that's, as I say, that's what I've lived for the last, 4 decades in software that I've built is, can I automate that? Can I optimize that? So I take that as a reasonable thing. Second statement is AIs will sort of have objectives that are kind of a wide range of different objectives. If you can define them as having objectives, I think that's kind of true. But I'm not sure what it means to say that they have objectives. Well, so then the next claim would be most of those possible objectives don't leave room for humans. That's a much more bizarre claim, I think, because it's like saying that, it's difficult to define this notion of an objective for something that doesn't have the kind of thinking that isn't human-like, that isn't. It's like I can say I've got this little program and it does what it does, but does it have an objective? Well, no, not really. It just does what it does. Now, do humans have objectives? Well, at some level, we just do what we do. The nerve firings in our brains cause us to do what they cause us to do. We, from the outside, will have a description that says that human is doing that because of this and that and the other. But that's a from the outside description. That is an imposed notion of an objective. Now, we may feel in our internal thinking about our own thinking that we describe our internal thinking in terms of objectives. That's possible. I'm not sure that that's a thing. It's an interesting question, to what extent the description of what we do in terms of objectives is something that is innate and natural, or whether that's something that we learn just as we learn language. For us to describe what we do as I'm doing that because blah, 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 it might be that, when we're all, babies or whatever, we just do what we do. And it is a higher layer that is our description of objectives, so to speak, just as it's a higher layer to be able to describe things in terms of language. So, I think this notion that we can just sort of say in the space of possible objectives here, the AI is going to pick this and this and this, then they're going to tighten the string. And when they tighten the string, humans will be sort of locked out of the picture. I just think that's I just don't think that's the right picture of what it means to think about sort of a space of objectives. I don't even know what it means to talk about an objective. It's like, asking one gets very quickly into a lot of kind of complicated ethical questions about kind of what, I think Eliezer has sort of an idea about that we have a responsibility to keep the universe interesting, so to speak. But I have no idea what that means. In other words, spreading life through the universe is that there is a sort of ethical obligation to the universe to spread life through the universe. I simply don't get that at all. I mean, ethics is a human thing. There is no abstract ethics. People get confused because people try to take ethical questions and couch them as scientific questions. For example, famous one is, the trolley problem. You are trying to decide, are you going to, make this, well, these days it'd be a self-driving car, kill 5 llamas or something, or 1 endangered lizard or whatever. How do you decide that? Well, the point is that the cheat in that problem is, well, in science, one of the things that makes science possible is that we can do kind of controlled experiments. we can say we're going to do an experiment on this little tiny piece of the world, ignoring everything else that's happening in the world. We don't have to, but in ethics, I don't think that's possible. In other words, there is no answer to the question of the llamas or the endangered lizard without knowing the whole story of sort of the connections of the llamas, whether that one of those llamas was somebody's pet llama, whether there was a group that worships llamas, and whether the endangered lizard was all kinds of things. It kind of quickly entangles everything in the world. You no longer get to do this kind of sciencey thing of making the controlled experiment the abstract kind of thing. I think you were asking earlier about what a person like me feels like in terms of kind of, is AI just going to be able to do their job for them and so on. Um, my attitude towards that is I spent my life trying to use tools that exist to leverage the things that I can do and to get me on the sort of fastest path from thinking of something to do to being able to execute it. And, for me, talking to the AI to have it help me write a piece of code or something like this is a pure, it just helps that process. Now, there's another thing that I've just started to do, which I'm not quite sure how well it's going to work out, but it's this. For example, we made a big progress in fundamental physics about 5 years ago, and there's a big question about whether there are experimental consequences of this theory of physics that are made, whether there are experimental consequences that one can figure out what they are. Maybe there are experimental consequences where the experiment was already done and people just didn't know how to interpret it. Well, there are millions of physics papers out there in the world. I haven't read all of them. I couldn't read all of them. So a question is, can I use AI to essentially thematically analyze all of those papers and tell me sort of thematically? I mean, it's one thing to sort of do statistics and say, I've got this whole pile of numbers, and 7 out of 10, giraffes have long necks or whatever it is. With numbers, you can do sort of statistics. But there's a thing that's now become possible with AI, which is to say, let's take a million pieces of text and let's try and extract something thematic from all of that text. Not what's the average of the numbers, but what's the mood of the text or something. And so, it's something I'm just starting to try to do. And it'll be interesting to see how well it works. I suspect it's going to work fairly well. And I suspect that's a kind of, is it a discontinuity from what we've had before? Not really, but it's another big step. I mean, back in the 1970s, I was already using online database services where you could do that people had uploaded the abstracts of all scientific papers. You could do a keyword search. You could find papers. That became a lot easier when the web came along and search engines came along. But it was already possible in the 1970s. The web made it easier to do full text searching and so on, search engines and such like. This is another step. I don't know, how significant a step it will be. I don't really know. I mean, there are many use cases that are kind of interesting. I mean, one that I've been curious about is medical diagnosis. Actually, diagnosis of almost anything. Diagnosis of, problems with your computer. Things where there's a body of knowledge about things that can happen, and you have certain symptoms, and you're trying to match those symptoms to what's known. And I kind of have this suspicion that, the current round of AIs is going to do quite well at that, possibly in a quite superhuman way. Because, we humans, I mean, it's this thing about sort of thematic searching of what's out there in the world. And it's some parts of that thematic searching actually don't even use the kind of most AI-ish parts of things like LLMs. They use things like, take a big piece of text and instead of grinding it up just into words, grind it up into these arrays of numbers that somehow represent the meanings of sentences. And then say, well, do I have a sentence that I'm now asking about that's close in meaning as revealed by being close in numbers to something which was already there?
Yeah, you mentioned something interesting, which is like what the fundamental question is, what do humans want to do? You talked about this idea of jobs. Yeah, there was a quote, I think, on an essay around John Maynard Keynes. He said that in the 1930s, he said that in 100 years, due to the advancement of technology, that the productivity is going to increase so much that humans are only going to need to work less than 15 hours per week. And you mentioned with AI and development of AI, humans are pretty much AI is going to be able to do what everything the humans are going to do. Yet here we are, pretty much 100 years later, humans are still working 40 to 40, 50 hours a week. So nothing's really changed there. What does
Yeah.
that say about how we identify as purpose? And what are the things that we need to unlearn as society if AI can really do everything that we can?
Well, I think, in the time of Keynes, lots of people were doing agriculture. I mean, lots of people were working very hard at things that got automated. And, as I was saying before, I mean, what we actually see in the data is what happened is those people fragmented into a zillion other jobs. Now, it's like a lot of these things. It's like the paperless office myth. When there are, when you can make documents electronically, there won't be any paper. Now there isn't much paper, but that took a while. There was a big burst of more paper, and I think that what I think we see is that the things, there will be, I think, more emphasis on, I mean, what do humans do? Humans make choices. Humans interact with other humans. These are things which are sort of uniquely human and independent. Even the interacting with other humans, I'm not sure how that's going to play out. I mean, we have a big project right now to build an AI tutor. People have been trying to do sort of computerized education for 70 years, and it's basically always failed. To do, one can get computers to help, but to be the prime teacher has never worked. It looks promising this time around. I'm not saying for sure it will work. We'll know. We'll probably release it in a few months, and then we'll know whether it works or not.
So like Khan
It's hard.
Academy style, or what's kind of the
Well, I mean, so this is literally you're simply interacting with particular thing we're targeting is algebra, because that seems to be a thing people have a lot of trouble with. It's frustrating for me because usually we build products and I'm in the target market for those products. This is practically the first product we've ever built where I'm not in the target market, and I have a pretty hard time kind of internalizing what the interaction looks like.
I'll be the
Um,
beta user because I'm terrible with algebra.
that's yeah, it's a thing where the question is, I mean, I think what the center of something like Khan Academy is videos that explain things, and I know they've done some experiments with LLMs. The raw LLM does not do very well at this. The thing that people might say the raw LLM is going to be able to be a tutor. It is true that if you like upload the class assignment that you had or the notes from your class and you tell the LLM, ask me questions based on these notes, it'll do a reasonable job at that. But if you say, lead me through this whole course and sort of keep me on track and so on, that's a thing that, at least in our observation, seems to need a whole lot of superstructure, a whole lot of kind of, I mean, for us right now, interesting statistic I just learned a couple of days ago, in our AI tutor, there's 4 times more sort of AI work going on in behind the scenes than the AI that's actually interacting with the student. So there's 4 times as much kind of the machinery that's keeping the whole thing on track and that's defining what should happen than there is in the actual, interaction with the student. And that gives you sort of a sense of the fact that, and it's a typical thing I think that's happening with sort of AI, is there's a component of a task that the current generation of AI is really quite helpful at, and it really, enables things which were never possible before. But there's still a big kind of, how do you fit that into a sort of harness of how do you fit that into a bigger machine that can do the full task you want to do? But back to sort of, so I don't know that, as far as I'm concerned, I'll know more in a few months whether sort of things that involve sort of things like teaching that seem to involve humans getting convinced of things by humans, humans getting motivated by interaction with humans. I don't know how much of that will turn out to be sort of AIable. Not sure.
But specifically around jobs and humans defining their identity around jobs, when AI is replacing everything, does the 9 to 5 need to change? Like, what happens when no one needs to work anymore?
Well, it depends what people, if people are, what does it mean to work? You know, if you're, if you're playing video games and that's how you make your living, is that working? What I do for a living, so to speak, I don't consider working particularly. I do what I do because I like doing it. I find it interesting. And, it happens to be a commercially successful thing. Much of what I do is. Some of what I do is basic science that might be commercially successful in 200 years, but that's not really, really the point, so to speak. I mean, I think that people have, the set of experiences people can have, the set of things people can do will be deeply leveraged by more technology. And as they have been so far, I mean, people who spend their time on social media, or make a living interacting on social media or doing podcasts or whatever else, these are things that have been enabled by technology. What we're doing right now couldn't have been done without a bunch of technology. And the in I think what we'll see is more and more things that are possible for humans to do. And yes, it's conceivable that humans will just all become couch potatoes and just you know and just be sort of pure consumers. But certainly the what has tended to be the case is there's certainly things for humans to do. It's not the case that there's that. I mean, if you ask the question, do humans need to work? In other words, can the world sort of operate without humans doing anything that anybody thinks of as work? I mean, it's possible. I don't think that's how things will run, because I think people will. It's like, well, we could say we don't need all those television shows that somebody had to invent. We don't need all those podcasts that people are doing and so on. The world could run without that. If we were back 100 years, we would say, yeah, you know, what we really need to do is to automate agriculture. Once we've done that, nobody's going to need to work. It's all good. We can just hang out and have food delivered to our table type thing and never have to worry about anything else. But that hasn't been that's not what has been the history of our species, so to speak. I mean, we end up with things where we find things that suddenly something becomes possible. It's like, well, people will do that. There's always a certain driver there's certain kinds of scarcity that I think continue to drive things. It's like, you could say, well, it's going to be automatic to discover this thing in science, let's say. Well, but if you decide to go in that direction, there's always going to be the first person who discovers that. And that's kind of an exciting thing, to be the first person who does this or that thing. There's always sort of a built-in scarcity to what's out there. I think the thing to understand, perhaps, is sort of the computational universe of possibilities is infinite. You might have thought that there'll come a time when we've made every invention that can be made. That time will never come. It's a century ago, people were like, yeah, we've almost made every invention that could be made. Well, turned out was not true, but we now know, a bunch of things I've done in sort of theoretical science make it very clear that in no sense will we ever be able to say every mathematical theorem that could be proved has been proved, every invention that could be made has been made. That will never happen. There is an infinite frontier of these things. There's an infinite, and every time there is an invention that can be made, there's something sort of new and different that you can do in the world. And then the question is, well, humans might just say, we don't care. It might be that humans just decide, if we look at human society, people have different beliefs about what we should be doing. I mean, it's like you could say, I don't believe in anything that was invented in the last 100 years. I'm not going to live my life in such a way that I'm using things that were invented in the last 100 years, last 1,000 years, whatever. Um, you know, you can make a decision that says, I'm just going to lock out the things that are now possible. Um, I think, just as one could have sort of the society of the couch potatoes, so to speak, that have just decided they're never going to try and do anything. I don't think that is the way the human condition is going to play out. But it's not something that, I mean, it is the case, well, in, depends on where you live in the world and how many people there are in the area. But, there are, if you're in a place where there are enough, natural resources that you can, just mine them out of the ground and, make a living, so to speak, just by the fact that there are these natural resources there. There are some parts of the world where that's the case. And it's an interesting question. What do people do in that situation? What do they do when they don't sort of need to do anything? And the thing to realize is, the human condition seems to be such that we still seem to seek some things that, for example, are scarce or whatever else. And I kind of think that it is somewhat on us. I mean, yes, it is already the case, at least for some small part of our species, that you kind of don't need to do anything, so to speak. And that would be, but I think that the question of whether you, it, I think it's more a choice than it is, oh, the AIs are going to take over, there's nothing for us to do. The fact that the AIs have enabled more things just puts us on a taller platform. There's more that we can then do. And at least, in at least my view of life, that's a thing that's kind of great and lets one go much further. It's not a thing where I say, oh gosh, I should just give up. The AIs can do everything I can do. I think, again, that's a somewhat, it might be somewhat person dependent thing. It's it's my perhaps kind of my rosy view of the human condition, perhaps, if you think about it that way, as something where people sort of always seek things to do, and whether they have to do it from the point of view of if they don't, they will die, or starve, or whatever else. It's a little bit of a different thing than is
Yeah.
that what they choose to do.
I agree with you from like the leisure perspective once you've met those basic necessities. But every human needs to put food on the table. Every human needs a roof. Most humans need a roof over their tops and be able to meet their basic necessities. And throughout history, we've always exchanged some form of value in the economy and work to be able to put currency, like the currency of money in our case, so that we can actually pay to meet those basic necessities. But what happens when there is not enough jobs and people don't have the ability to provide value to be able to actually exchange and meet those basic necessities? Is that a problem that you can solve through other economic means like UBI, or how do you think about that?
I think maybe I have okay. So the first point is that a lot of what people pay for in the world today isn't basic necessity, but not in all countries, but in in there are many segments of the world in which what people are mostly paying for isn't basic necessities. So there is a thing that people care about paying for that is something much more ethereal than just getting enough food to eat, so to speak. So that the question of what fraction of what has to be kind of paid for, there are a lot of things. Okay, here's a surprise. Something that surprised me, okay, is back, I don't know, 40 years ago or something, 45 years ago, I used to have fancy computers. I used to have access to computers that were much fancier than the typical person's computers were. But in fact, consumer electronics became cheap enough that everybody has the same kinds of computers now. It's very flat. And, you know, this question of it could have been the case that there was a huge, sort of consumer electronics was this thing that was a big sort of mountain where you only got to the top with a lot of effort. You know, things like basic necessities, they'll get cheaper probably. Through automation, they'll get cheaper. They've gotten cheaper. I mean, when fertilizer was invented, people thought the world was going to run out of food because there weren't going to be enough crops produced to deal with the population increase. But then things like fertilizer, crop breeding, and so on were invented, and and that problem went away through something, and because food effectively became cheaper, and food became easier to produce. And I think this question of uh, what happens when you've kind of zeroed out certain kinds of basic necessities. Well, people want other things. People want to see that. They want to watch that amazing special effects television program or something. They want to see this thing. They want to be kind of. They want to have this or that experience. They want to do these things which are kind of. That they. I mean, again, it's been the experience. Now, it could be the case that at some moment, sort of, our species or some segment of our species just decides we've got enough. We don't have to invent anything new. We just hang out. I think it's happened in the history of our species. I mean, people say, I don't know the detailed anthropology of it, but people say there have been periods of thousands of years where there have been, groups where, well, here's the funny thing, where people say, their basic necessities were taken care of. They lived in a place where they could, just pick berries off bushes to eat and so on, and then you ask, well, what did the people do in that situation? And a common anthropological statement, I haven't really dug deep in this, so I don't know how much I believe this, but the statement that's made is, well, people do these go into these very ritualistic kinds of behaviors, which is to say, from the outside, doesn't look like much is going on. It's just people doing, quotes, ritualistic kinds of things. I'm amused to realize the extent to which so many of the things we do today could be seen as ritualistic. I mean, from the point of view of, if you don't know why you're doing it, I'm sitting in front of a computer getting weird pictures coming up on the screen. This seems like a devotional, ritualistic kind of activity. If you don't have a thread of understanding what the point is, so to speak, in other words, if you can't connect that kind of activity to something that you intrinsically know what the point of it is, you can't make that kind of thread of connection. It just looks, quotes, ritualistic to you. So I think, the thing that sort of, what do the humans whose needs have been met, what do they do? The answer might be, from our view today, they look like they're just doing ritualistic kinds of things. But to their internal view, they're doing things that are tremendously significant. I mean, if I see some kid who's worrying about something, about some social media interaction they're having, it's like, I don't know why you care about this, but to them, it's something very important. And, from the outside or from a different time in history, it might not look important. But in the moment, in the internal sort of experience, it can look significant. And my guess is that there's a view of sort of the future which says, well, we'll figure out brain uploading and all this kind of thing, and pretty soon, what the future of humanity will be, a trillion souls in a box playing video games for the rest of eternity.
Mm.
Okay.
Yeah.
And
Yeah.
you might say, gosh, that's a terrible outcome. From our point of view today, from our experiences today, from the things we care about today, that seems like a terrible outcome. But my guess is that in the internal experience of that disembodied soul, playing quotes video games, will be perfectly meaningful. And they'll look back at our time and say, gosh, that must have been, they couldn't do all these amazing things we can now do. And, what a boring, meaningless existence, so to speak.
Yeah, just like 1,000 years ago, us running around treadmills seems crazy, like you mentioned. As the trajectory of technology advancements makes luxury items more accessible, you talked about. I mean, now everybody has a private car through Uber. You can, rent an Airbnb on wherever you want in the world and just go into someone's homes. Soon, you'll be able to have a robot in your house and tens of robots assistants can do pretty much anything for you. So if that's the case, and you're saying that basic necessities are going to be met, what what's going to be the perspective of how we think about money and wealth in general? Like, are people going to want to be wealthy in the future like we do today, or is that relationship with money going to change?
There'll always be scarcity. Not because, there'll always be the person who lives at the top of the mountain. There's only one top of the mountain. Maybe you can build another mountain eventually.
Mhm.
There'll always be the first person who does X. So there'll always be things that are not, genericizable. You may not care about them, but there will be things that somebody might think was worth kind of bidding up, so to speak. So I think that's one thing to realize. I think that in I mean, one's attitude about uh, you know, I've lived a life where I like to do interesting things I find fulfilling. I've I'm practical enough that that activity has made me a very decent amount of money, but it is not, for me, there have been a vast number of forks in the road where it's kind of like, do the more interesting thing, do the thing that makes more money. I'll always pick the more interesting thing, you know, to some people's kind of horror in a sense. But I think uh, it's a thing where, I mean, people in this question of whether, I think there's a lot of currency in the world that isn't money that exists right now. I mean, there's currencies, there's social currency of, do you have friends you like? There's kind of fame currency. There's a lot of things which are not money related. There's already lots of different kinds of things, and the question of the sort of the money as the thing that buys you food and so on may or may not be kind of the the thing. I think an interesting question, the very concept that there could be a single sort of store of value and its money is an interesting concept that's worked pretty well in thinking about economics. I'm not sure. I don't know. It's a thing I'm hoping to think about actually. I
Well, we
haven't
could
really
brainstorm.
figured it out. But you know, it's like people sometimes say you can buy anything with money, but it's actually not true in the world today. It's and it's like the things, I don't know, I've done in figuring out stuff in science, for example. I've had a really good time doing some of that. You could pay as much money as you want. It's not going to help you have that experience, so to speak. It's it's something where there are things you can do that sort of on ramp to that, but it's not a thing you can buy with money kind of thing. And I think that's one thing to realize in the way that in you know there's what you need for the basic necessities and the sort of economic model that exists. I mean, this whole question of uh, what value really is in the world. It's an interesting question. I'm actually, some science that I've done looks like it begins to tell you a bunch of things about how to think about economics. This is a very different topic, which we are not going to have a chance to really dive into, I think, here. But and also I haven't figured it out. I
Yeah.
mean, I've been it's a very strange thing that this physics project that kind of got launched 5 years ago has led to kind of a formalism for thinking about things that, in fact, in the last year has let me understand a bunch more about biology and biological evolution, a bunch more about machine learning. I'm pretty sure that it has a bunch of things to say about economics, but I don't yet know exactly what those are. But things that are kind of exercises, in a sense, for that economics is things like, if you take cryptocurrency, is it really worth anything? Or does it have to be the case? Which, by the way, relates to the question you're asking, because people might say, well, cryptocurrency isn't worth anything really because I can't go, buy food with it. It's not practical to go buy food with it. So therefore, it isn't really worth anything. I think that argument is not correct. And that relates to this. I mean, in a sense, it's worth something because there's this whole network of things that depend on it, on its existence and so on. And I think that that's again an example of something where you could say, well, all the value in the world is the fact that we have, houses and food and things like this. But yet there are these other kinds of value that seem to exist, and that so I guess I feel like the this question of the importance of sort of, you know I mean, in times in the past, having enough food still a problem in some parts of the world, but in many parts of the world, having enough food to eat isn't the problem. In fact, the problem is usually you eat far too much. Um, and in whereas at a different time in history, that would have been the big stretch goal, as get myself enough food to eat. I mean, I think when there are all these portraits of Henry VIII looking extremely rotund, that was a sign of that was a a sign of success, that you could be extremely rotund, because most people couldn't get enough food to eat at the time. It's I think in I think this question of sort of what will people be doing with themselves in the future? It's will they, will work look the same? Work has changed a lot. I mean, before the Industrial Revolution, work didn't look anything like the 9 to 5 work looks today. I mean, mostly people were sort of working for themselves, you know, you know, tending crops and things for their own use, things like this. Then things got streamlined and centralized, and now there's a little bit more of of people doing more sort of working for themselves, so to speak. I don't know whether the picture of and there's a little bit more. Another thing I've noticed. I don't know. I don't really have data about it, but you know, more people have more different things that they do. I mean, there was a period of time when you say, "What do you do?" It's like, well, you know, I'm a this. It turns out, well, I'm kind of a this. That's my day job, but then I do podcasting, and then I do, competitive, bicycle racing or something, and then I do whatever. And it's that I think, even independent of the economy fragmenting into many different job categories, even people's individual lives, people are ending up having more tracks in what they do. And I don't really know how that, maybe part of the reason that's possible is because the cost of getting into those tracks has gone down. That is, it was, take podcasting, for example. If you wanted to be kind of a person who would broadcast things to the world, that was, you had to build this whole stack of things. You had to go work for a radio station or whatever else it is. But because of technology, the cost of getting into the business of podcasting went way down. So we can do that as a gig, so to speak. We don't have to have made it our whole life. And my guess is that that's probably a trend that of people sort of doing a bunch of different things. Another interesting question is whether there was a period of time when people would do one job for their whole life. One, sometimes, and the question is, and that's often still a great thing. Sometimes you can be working in one place, but what you do can change completely. But I kind of think this idea, I think this fragmentation thing, which is sort of, again, relates to, it's more about the choice than it is about the mechanics of what's done. I think that, the mechanics of what's done getting automated just means there are more choices, and maybe that's manifest in both more kinds of jobs and more jobs done by individual people and so on. It's my guess. I mean, I'm, the idea, as I say, there could be a choice to just sit around as a couch potato, and maybe there'll be, a segment of society that does that. And an interesting, I don't know what, and maybe from our point of view today, that looks like a pretty bad outcome, just like the trillion uploaded souls looked like a bad outcome. But I don't know. For me, I'm not a very good couch potato, so to speak. And I don't, for me, if I'm like, there are plenty of things that lots of people find interesting that I don't. Like, I don't watch television. I don't play games. I don't, do it's just those are things that I personally don't happen to find interesting, but other people find those things absolutely fulfilling and interesting. And it's not, I wouldn't make any claim that there's anything about my particular interests that is in any way more wonderful than other people's. It's just the particulars of what I'm interested in. And, I think again, that's probably another thing that will be true as more gets automated. Each of us with our particular interests and foibles is capable of sort of pursuing those things in a way that wasn't possible before, because the sort of the barrier to entry, the amount of mechanical stuff that had to be done was so great that, well, like podcasting is a good example, really, of where you just couldn't have done that without the levels of automation that exist today. And I think that that's sort of in a sense, maybe it's perhaps this is an overly optimistic view of things, but we're all kind of forged with different interests and objectives and things we care about and so on. That's a pretty arbitrary thing that will be some kind of mixture of genetics and physiology together with our experiences. But, we're all in this position where there are things we care about doing. And one could argue that what's happening as more gets automated, as the world becomes more and more ergonomic for us to be able to do what we want to do. In other words, in the past, it was like, well, we have this and this and this thing we want to do, but gosh, I'm never going to be able to do that because it's just too hard. But as more and more gets easy, it's like, well, there's this and this and this thing that I want to do. Well, okay, great. Now I can actually do it. I mean, again, story of my life has been that the things I've been really keen to do, I have built a big tower of automation that makes those things reachable. And without that, I wouldn't have been able to do these things. And it's been even in recent times, actually, I've been doing particularly a lot of science that's quite diverse in the kinds of things I've been doing. And it's, from a point of view without the technology tower I've built and without a certain amount of scientific knowledge that sort of I've accumulated, it would be completely inconceivable to go across all those different areas. Just like, that's just crazy. You can't, write something about biology 1 month and about machine learning another month and about foundations of mathematics another month. That's been made possible because I automated a whole bunch of stuff. And, I think that's what, that's sort of the thing that as I'm talking to you about it, I'm realizing this really is, I think, the picture is it's kind of like, we all have lots of things we want to do, and the barrier to entry to most of those things has been too high for us to actually do them. As more gets automated, we'll be able to do them. Now, what that will mean in terms of, what do we get for that? Well, we might get money, we might get some other kind of currency, we might just get internal fulfillment, which is perhaps its own currency, so to speak. It's sort of the personal currency. And, but I think some aspects, just like the putting food on the table, became less of a stretch, over time. So it may very well be the case that certain kinds of things that are, as I say, this whole question about like consumer electronics, I could have, if I, okay, as a practical person who, makes choices in their life and so on, and it's like, well, okay, I could do this and I would make a bunch of money doing it. I, at a very practical level, have thought about what do you get to do at this level of money, that level of money, and so on. And it's interesting. There are these different levels of what's possible. Now, I'm been fortunate enough that I'm not dealing with the, make the rent payment type level, but but it's sort of interesting that there are things at different levels where it's like, yeah, one could, get the money to buy a yacht, but I don't care. That's not something I'm interested in. One could do this or that thing and plenty of the things that I do, for example, are things where it's just not a question of money. It's a question of, to be able to do it is a question of other kinds of things that are not directly money.
What do you think is the right amount of money for someone to make where people can just stop caring about that and just pursue what they want to do for, let's say, the US?
It's an interesting question. I don't know. I mean, I think that uh, I think there was an image right in the 1950s or something of the little house with the white picket fence and so on, and that people, that was kind of the image of sort of the normal thing people would be, you know, would want, so to speak. And I would say it's sometimes it's a complicated. Be careful what you wish for. I have my main house is a great house that we built years ago. That's really big, and our kids have all moved out now, and now it's kind of too big and a big pain in the neck. And but so it's sometimes it's a uh, uh, it I don't know a number because it depends on. I mean, I think if I'm to look at my own, for me, I mean, it depends on the level of what you want to do. For me, you know, I do projects where I might burn a few $1 million and where the
Yeah.
project might not work out. What's that?
And you're like, oh, there it is.
Well, and that's the. But if somebody says here's a project where it would cost $100 million, I'm like, I can't do that, right? So, in it's a thing where um, it's a now, you know, if I suppose that the things that I'm interested in doing are somewhat titrated by the resources that I have to do them. I mean, I don't happen to be interested in, you know, building rockets to go to Mars or whatever, a very expensive endeavor. I, you know, it's kind of an interesting thing, perhaps, in this physics project of mine, I might suddenly become really interested in doing a physics experiment that costs $100 million. And
So
so,
what happens then?
maybe, what's that?
What happens then? Are you going to care more about making money then, just so you can pursue those
I
paths?
don't know. I think that'll be a kind of here it is world. You can, I mean, in that particular case, a funny situation because for myself, I'm kind of convinced enough that this theory of physics that we have is right, that seeing the experiments happen will be cool, but it'll be mostly a okay world, now you can believe me type thing, which
Mm.
is not something I care that much about. So I think I don't know. We'll have to see. It's very hard to predict how one will feel about things until they actually happen. But I think in that case, it's kind of like it'll be okay. Well, you can do this. It's going to cost $100 million. I think it's worth doing. If you care about finding out whether I'm right or not, go do it. Not on my dime, so to speak. But I might change my mind. I mean, you know, I might be. I think in it's a thing where it's always a complicated thing. What there are plenty of things that I've done. For example, the science that I do is mostly not very expensive. I mean, it's kind of the people who help me with it and so on, and that's it costs a certain amount, but the theoretical science is not terribly expensive. In fact, sometimes these things defeat themselves by being too big. In other words, even it happens with lots of things, but it happens. If you've got this small number of people working intensely on something, and there's a lot of flexibility in what's going on, you say, well, actually, I'm going to have 1,000 people work on this. You end up with necessary structure. Otherwise, just it just becomes a total mess. You have structure. That structure kind of reduces the kind of the level of flexibility and innovation that becomes possible, and it's then a complicated sort of management issue to sort of carve off the piece that's going to be the innovative piece together with the piece, that's going to be the mechanical piece that actually gets the thing done. But I think I'm uh, I'm bad at I'd have to go look at the cost of living data that we have in Wolfram Alpha and so on to have any kind of meaningful thing to say about what. I mean, I'm sure if you'd embarrass me if you started quizzing me about how much do different grocery items cost and so on. I have no idea. I mean, I it's I you know I know that it's just like it's there's a for everybody. I think there's a there's a level of I don't really care about the pennies type thing, and where that set point is depends on lots of things about how you lead your life. But I think in uh, you know this question of when will it be the case that most people say I've got enough money, I don't need any more. That will never happen because there'll always be scarce things that are scarce where people say, I want to make more money so I can get, some people will say, I want to make more money so I can get that scarce thing. I think that, for myself, for example, I guess that for me, it's like I kind of feel like I know, I've been fortunate in that I've generally been in a position where I've kind of can do the things I want to do. I have the resources to do the things that I want to do. Now, maybe I'm kidding myself because really, if I had more resources, I'd think of a lot more things that I could do. I don't think so. I think that it's kind of a thing where well, the other thing that I see happen a lot. I remember, well, you know, you see people saying, "I can't do that because I don't have enough money to do it." Sometimes that's true, but a lot of the time it's just not true. A lot of the time it's just deciding you're going to do it and there'll be a way to do it and it doesn't really have anything to do with the money.
Being
That's
more
just an
resourceful.
excuse. Right.
Yeah.
It's just an excuse for I don't really have the initiative to do that thing. Oh, if I had more money, my life would be cushier and then I'd get the initiative to do that thing. That maybe that happens that way for some people. I mean, look, I know that, for example, if I, there have been times when our company has done particularly well and where at least one of them is correlated with a time when I sort of put more effort into basic science. And so perhaps, and I can't say, for me, that wasn't really a causal connection but maybe it was. Maybe there was a psychological connection there of, oh, I don't have to put so much effort into, technology development because we did really well recently on that. And so that sort of tips me into more, oh, I can put effort into basic science. I'm not sure. Um, so, it's hard to tell, even from the inside, it's hard to tell what exactly is leading you to different kinds of motivations. But I have to say, I've seen an awful lot of cases where people explain, oh, I can't do that because I need more money. And it's just, not true. It's a matter of initiative. And it's, I had a charming case actually many years ago now. I kind of have a hobby of doing uh, kind of CEO counseling and of advising companies and so on. And I also have always found it interesting kind of mentoring kids. And I kind of noticed at some point that those two categories, both of which I found interesting, were the category of kids and the category of CEOs. They're types of people who believe that anything is possible. And there are lots of other people who don't believe that anything is possible. They're kind of like we're stuck in this particular track we're in. But those two felt that it's kind of a more in the anything's possible. And I happen to have this. I was doing I have this try and make my life efficient. And when I'm driving from here to there, I'll make phone calls and things. And this was I had a phone call with one kid and then one CEO, and the kid was explaining that couldn't do this or that because they didn't have enough money, et cetera, et cetera, et cetera. And the CEO I was about to talk to was about to sell their company for and about to make about $50 million. And I was telling this kid, this next phone call I'm going to do, this person, because I already knew what some of the issues were, was going to tell me they can't do this and that and the other thing. And they said, but clearly money is not their issue. So the reason they can't do these things is not because, they don't have enough money, which is what the kid was saying, but because of something else, that some internal kind of, block of I just can't do this because I don't feel confident in doing it. I don't have the initiative to do it, et cetera, et cetera, et cetera. This kid told me that was a useful conversation. and he went and did the thing that he was thinking about doing, and it worked out pretty well. So, but it was, it's sort of interesting to me, you know, you see those cases where it's it's a people. Uh, I don't know. I'm not answering the question. And if you ask me, if we could distribute UBI from AI to everybody, would the world be a better place? I doubt it. I mean, I think that people, the experiments people have done, the situations people have, where it's just like, now you reset the base level and everybody has this. Still, people are going to seek the scarcity and so on. Some people are going to seek the scarcity. Some people are going to, I mean, it's a thing that's always, one of the things that is kind of a negative value of money story. I mean, I always notice there's positive value of money and there's negative value of money. Sometimes you see, I know plenty of people who've been bitten in so many ways by the negative value of money, so to speak. Um, you know, in I mean, just there are more than we can enumerate of things where, but a very there are typical ones that everybody knows about I inherited a ton of money, now what am I supposed to do with my life type thing, or you know or there's this pot of money and people who would otherwise be friends are arguing to the death over it, so to speak, even though if that pot of money wasn't there they'd just be happily friends with each other. There are all these different scenarios, and I think it is complicated, and it's something where I don't think just like I don't think it's true that you can buy anything with money. I don't think that injecting some amount of money into the system is I don't think that solves everything, so to speak. But I it's but this is getting far out of my usual. This is me as
We went
just
too
common
far.
sense observer of the world.
Yeah.
I'm not. It's not. You know, I I can only say that I think I do think that the sort of the AI makes it easier to do things is another thing to say, I suppose, is that people have different skills, people have different interests. One can be lucky or unlucky in the period of history in which one lives. So, for example, I consider myself lucky to have been in a period of history when computers started being sort of usable things because they're a good fit for a lot of stuff that, I like doing. You know, if I'd been sort of obsessed with finding, exploring the surface of the earth or something, I've lived in the wrong time in history because we got satellites that took pictures of all of it. Um, I think that there are times in history when if you were sort of an intellectual and you had a bunch of, I really want to think about ideas, it's like, sorry, you have to, plow the fields to get the food, or you have to fight in some army to, not have your world collapse type thing. I've been lucky enough to live in a time, be in places where, it's been sort of peacetime everywhere I've been, at least in the more or less, in as an example. And I think one can be. I think this question of another thing, there was a time when if you were a techie type of person and you were doing things in business, it was like, oh, you're just a techie, you're off in the back room, so to speak. And then at some point, the techies, the nerds took over, so to speak. And then it was like, it's pretty cool to be a techie doing business kind of thing. And you know, you can be you could be very frustrated in it, being the techie who really wants to be calling the shots in the business, and everybody's telling you, no, the professional managers will do that type of thing. And so I think, what's coming is, I do think that what's coming probably is a time when, if you like thinking, this is the time for you, so to speak. If you like having ideas and so on, this is the time for you. If you like kind of doing the mechanics of doing things, maybe it's less the time for you. I mean, and maybe that's a, and it's a thing where I think, there are, because the things which are sort of more mechanical are getting automated and will get more automated. Um, and so that's a, and I think for people, and it relates to what people learn in education and so on, because a lot of education in the last 100 years or so has been a lot about the mechanics of doing things, and it should be more about, you know, learning the facts that you need to know to be able to think broadly about things, and then learning how to think broadly about things. But that's not been the sort of industrialized form of education that we've tended to have. I suspect that will become more and more important. I tend to think that sort of the extremes of kind of philosophy as a way of thinking about things, and computational thinking as this kind of formalized way of thinking about things, these are two good sort of forms of thinking worth learning, so to speak. And those are things which I think will kind of in the coming world where lots of the mechanics have been automated, those become things that are very significant for people to be able to do. And and if you like doing those things, now's the time for you, so to speak.
Based on this idea of what's coming and things getting automated, we're entering this time now, particularly in the world of software, where we can put up a prompt and you can create software. So, like, there's Replit, there's Windsurf, there's programs that are out there now where you can create an app, create a website within minutes, which would normally have taken weeks or months or years even. So this idea of creating software, people are saying, is becoming more of a commodity. And you can kind of see this world of like just the way we can publish podcasts in such a seamless way that distributes around the world, that publishes on YouTube or Spotify, is similar to the way that you're going to be able to publish apps on the App Store. And it's going to be this kind of this hybrid of like YouTube meets App Store, people are
No,
saying.
I don't think so quite. I mean, you've got to understand,
Okay.
you know, and actually I need to go soon, but
Yeah, yeah.
the
Just
the
we can end it here.
um this whole business about automating software, that's what I just spent the last 4 decades doing. People who use Wolfram language, they go from ideas to stuff that runs in amazingly short amounts of time. The fact that there is this whole ecosystem of people doing manual labor software development is just bizarre. I mean, it's happened because of a bunch of the economics of labor, a bunch of the ways that technology is developed. But the fact is, you say you can create an app in, that's what I do many times a day, writing tiny amounts of code. You know, it's that's what, that's been my objective, is to automate those things. And the fact that, I mean, what's happened is that there is a craft of software engineering where it's like you get a spec, you spend 2 weeks implementing the spec. Often, it's a funny thing to see in companies, the people who run them, the CTOs, the CEOs, and so on, actually use our tech and build prototypes of things in a very short time. And then they go on and they figure out the next thing they want to do and build that as well. But the people who are now sort of in the trenches doing software engineering are like, well, we just got a spec. We build to that spec. Okay, now if we could do that much more quickly, which they can with our tech, then they're like, well, now I've got something very difficult to do. I've got to make a new spec. That's not what my job is. My job is to grind out code. And yes, this is exactly an example of where the mechanical stuff is getting automated. I mean, that particular one I know very well because I just spent the last 4 decades doing the automation of that one. And and people have, the fact that you can go from more like a natural language description to code is something which, plays very well into our tech stack. But, some part of that is, and then you can write a blob of Python code, which would just be one function in our language anyway. You wouldn't be writing that. But the AI can write that. But I think the thing to understand about things like software is, and it relates very much to what we've been talking about a lot in this conversation, is you say, you snap your fingers and then there's an app. Well, what is that app supposed to do? You have to describe what it does. and that is making a choice, so to speak. And the description of what it does is the thing that's going to be of value. It's not the mechanics of, and with our tech stack, for example, and all the people who use it, the 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 kind of mechanics of doing a lot of things, those have been zeroed out for years. Those are not. I mean, which is great. It means one's been able to go further in lots of things, in lots of kinds of development and science and so on. But that so the thing, it isn't just, okay, make me an app. What the heck's the app supposed to do, right? It's like you have to say, you have to conceptualize, I want an app that's going to do this, and then you start to sort of dig into, well, okay, how are you going to build that, et cetera, et cetera, et cetera. So it's actually that is a really good example of the things I've been talking about, namely, what becomes the human act is, what do I want it to do? Then, as I say, in that particular case, I've spent the last 4 decades trying to do that automation. AIs add another level of automation to that. But it doesn't get you around the, you kind of, it's like there's still somewhere you have to decide what the app is supposed to do. And I think that's and yes, that's a thing where you're, again, that's what I've been living for many decades now, is getting to the point where it's mostly about imagining what the app is supposed to do, not about the mechanics of actually writing it.
Wouldn't that still, regardlessly, increase the supply of software significantly, just like podcasts have significantly increased? And if that's the case, what's the moat for a software entrepreneur that you're advising if software used to be hard and now it's easier and there's more supply than ever?
Well, I mean, it's a question of what does it do, right? So in what I've done in my life, probably the thing of highest value, I think, is the design of our computational language. In other words, the implementation, sure, that's valuable. It's cost a huge amount of money to do it. And, people use it, every day, all the time. But for me, it's actually an interesting thing you should say that, because for me, the thing that is really of the highest value is what I've spent lots of effort on, which is kind of the functional design of the language. I mean, we live stream many of our sort of software design meetings. So there's now, I don't know, there's 1,000 hours of actually what's involved in doing that out there in the world. It's actually a very interesting intellectual activity, but that's the, I suppose, in a sense, it's, you could take that spec and you could re-implement it. Good luck with that. I mean, that's a thing where it's a, I think I have an idea. There are so many different kinds of moats. I mean, there are moats to do with, I've got this, social media platform and all your friends are on it. You should be on it too.
Yeah.
There's we've got this sort of unique intellectual property that we've been able to build, and that's the main tower we have, and it's and that for example, in our tech stack, we have been using various forms of machine learning and AI to help with software development for a long time. I mean, a lot of what we have to do is make meta algorithms that select between algorithms. And that's a thing for which we've used machine learning for a long time. It's, again, the strategy of what's happening inside, which is a lot of human choices, is still a thing that you don't get to zero out. I mean, I think, my company is about 800 people, which is really kind of tiny relative to what we've been able
tiny.
to produce.
Okay.
It's I think relative to the amount of software we've produced, how has that been possible? Well, it's because we've automated the heck out of things, and we're building on sort of a, we built this tower where we're kind of recursively able to do more because we've automated the last thing we were able to do. So I think, it's an interesting question. What I think it's really what do the space of possible software, it's like these little programs that I study in the computational universe. Every one is a piece of software in a sense. Every one does something. Most of them are not things that anybody would care about. Some of them make really pretty pictures. Some of them make good cryptographic systems. Some of them make good image processing filters. Those are ones where we've been able to kind of mine what's out there and turn it into something that we find useful. But the leading piece to that has to be, well, what do you want it to do? What is the thing you want? So if you can say, well, is there going to be a broader set of things that people want software to do? Maybe as people's activities broaden out, there will be a need. I mean, like, for example, well, take podcasting again. There's a bunch of software around podcasting that didn't need to exist until podcasting existed. And I think that will be, in terms of the expansion opportunities. I mean, I always see this in terms of technology. There's sort of technology that comes over the horizon that enables things. Like, one that almost came over the horizon a bunch of times, but still is firmly sitting at the end of the rainbow is VR or XR in general. It's kind of like one day that will really come over the horizon, and that will enable a lot of new things, which it's like, how do I manage the post-it notes, the virtual post-it notes that I put in my environment or whatever? There'll be an app for that, so to speak. And that, as the general tide of technology rises, so there start to be more and more things where we now have to figure out, well, what are we going to do? What particular direction are we going to take? And I really think it's very much the same story as the story of AI, that, more becomes possible, more becomes automated. Now it's a question of what do we humans choose as the next step that we want to do? And talking of next steps, I need to go and
I think that's a great closing
step.
question for someone listening to ask that question is, what are we supposed to do? Stephen, thank you so much for coming back on the show. This was such a intellectually interesting and thought-provoking conversation as usual. Where can people find you online, if that's something you even care about? I don't know.
StephenWolfram.com is a good place to start.
Yeah.
And that has... you can also find me on all the usual social media platforms, and you can find, I do I guess it's a podcast. I do live streams a couple of times a week, answering questions and so on.
Beautiful.
So those are places people can find me.
Beautiful.
Anyway,
thank you, Stephen.
Well, thanks for lots of interesting questions. That's
Thank you.
been fun.